Okay, so today we're going to start for B7. Is rational expression. So what's the meaning of rational expression? Definition. So a rational expression is exactly a fraction expression a fraction expression such that both of the numerator and denominator are polynomials, such that both of numerator and denominator both of them are polynomials. What does that mean? So rational expression look like this. So I have rational expression. This is equal. I have fraction. Here I have polynomial. And here polynomial. So let me give you example and you have to tell me which of them are rational expression, which of them not the rational expression. Which of this is rational expression? First one, if I have something like that, 2x over x minus 1. Number 2, y minus 2 over y squared plus 4. Number 3, x over square root of x plus 1. Number 4, x squared minus x to the minus 1 over x to the power 1 over 3 plus 2. The first one is a rational expression, and why? Who will solve the first one? Is it a rational expression? So you have to check, is the numerator polynomial? Is the denominator is a polynomial? If both of them are polynomials, then it's a rational expression. 2x is a polynomial? Yes, it is a polynomial. X minus 1 is a polynomial?
Yes.
Yes, it's a polynomial. So this is, yes, a rational expression. The answer is yes. It is a rational expression. Why? Because 2x and x minus 1 is both of them polynomial. Because both of 2x and the second one, x minus 1, are polynomial. Second one is a polynomial. Second one here, y minus 2 over y squared plus 4. Is it a polynomial? Yes or no? You have to ask yourself, is the numerator polynomial? Y minus 2?
Yeah.
Yes, it's a polynomial. Is the denominator polynomial?
Yes.
Yes. So polynomial over polynomial, this is a Rational expression. So yes, because y minus 2 and y squared plus 4 are polynomials. This one, is it a polynomial? X over x minus square root of x plus 1. Is it a polynomial?
No.
X, no. Why? Can you explain why?
Yeah. The square root of x plus 1.
Is not a polynomial. That's true. So for the numerator, x is a polynomial. This is true. But for the denominator, square root of x plus 1 is not a polynomial. The denominator is not a polynomial. So the answer is no, because square root of x plus 1 is not polynomial. So to remember the definition of polynomial, just go back to the previous sections, okay? Or I will explain here, polynomial is, what is the polynomial? Anything look like a n x to the power n plus a n minus 1 x to the power n minus 1 minus 1 plus plus a1 x plus a0, such that an minus 1, a1, a0, all of them real numbers, and n here must be natural number or 0. Okay, these things here in the denominator is not look like a polynomial like this. So the attendance sheet, I'm going to put it in the link down for who asked me about the attendance sheet. Here is it. Go over this link, just sign your name. Fourth one, is it a polynomial? Fourth one, is it a polynomial? This one? Does this one fraction polynomial?
No,
I mean, a Rational expression?
it's not.
Is not Rational expression. No. Why? You ask yourself, is the numerator polynomial here?
No, because
No.
of the negative to the 1 power.
Exactly, because the exponent here minus 1 and the exponent minus 1 is not natural number. So this is mean this expression is not a polynomial. Here in the denominator, the same things. Look to the exponent for x is 1 over 3, and 1 over 3 is not natural number, is a rational numbers. So because it's not natural numbers, this is mean this expression is not a polynomial. No, because both of the numerator and denominator are not polynomial. not polynomial. Any questions so far? So now we learn how is the look like for rational expression. Anything look like a polynomial over is a fraction such that numerator has polynomial, denominator is a polynomial. Any questions so far? Before we go to the next slide. So now we learn how is the look like for how is the rational expression look like. Now we're going to learn something is called the domain of algebraic expression. So first things, what is the meaning of domain? Have you heard about this definition before, domain? Somebody hear about, what is the, okay, what is the meaning of domain? Can you give me the definition or what is, any idea
Usually,
about?
when I think about domain, I think about a point. I forgot what else it had to do with that.
Okay, point, exactly. What else?
I think the domain is like the X value.
The domain, the X value, yes, exactly. It's like, it's, I mean, like not the, yeah. So who will give me like more like information about domain? Someone over there, he said like the X value.
The
Someone there,
domain is like a range of X values.
the range of X values, exactly. So I can like explain the domain as a set, right? Like set of numbers, of real numbers, such that if I plug these numbers inside the expression, I make the expression will define. Okay, like how can I make the expression will define? Some expression cannot plug any numbers inside them. Why? Because they make the expression undefined. Like for example, 1 over x. Can I plug the 0 inside 1 over x? No, I cannot. Why? Because 1 over 0 is undefined. So I'm going to, let me first here give you the definition of the domain is a set of real numbers such that makes the expression define. Now let me give you example to know how to find this set. Now we're going to find what does this set look like. So I give you example, and by this example I explain the domain more. So I have expression and I have here domain. So first expression is 1 over x. Second one is square root of x. Third one is 1 over x square root of x. So you have to ask yourself, what's the value of, can I plug in this expression that makes this expression define. Can you plug zeros? Can you plug positive numbers here? Like 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 5. It will be like, it's accepted to plug any positive numbers here in this expression. Can I plug any positive numbers here in this side, this expression?
Yes.
Yes, I can. Why? Because if I plug any positive here, they will stay defined. Can I plug negative numbers? Any real negative numbers?
Yes.
Yes. So yeah, I can plug any negative number. Why? Because when I plug any negative, it give me the expression will be defined. Why? Because, for example, take -2. 1 over -2 is equal -half, and -half is defined. What about the 0? Can I plug the 0 here inside this one?
Yes.
1 over 0. Yes, 1 over 0. It's defined.
Oh no.
No, it's not defined. This is mean I have to remove the 0 from this set. So my domain is all the numbers except the 0. Make sense? So the domain, I can here write all the numbers such that x not equal 0. Okay. So here x such that x not equal 0. This is mean, in other word, all real numbers except the 0 number. For the second one, can I plug positive numbers inside the radical? Before anything, this is, if I want to write it again, this is the square root. Look like this. I said for any even number before in the previous class, the even number is 2 here. 2 is even number. 2, 4, 6, 8, whatever. All of these even number greater than 0. Any even number must inside this radical here positive. X must be positive. I mean like square root of 1, square root of 2, positive number, any positive number. Okay, let me go back to the question. Now the question is find the domain. Find the set that it's possible to plug it inside this expression such that makes the expression will define. Can I plug the 0? Yes, I can. Why? Because the square root of 0 is 0. So I can plug the 0. Can I plug positive numbers? Yes. Why? Because I said here is even number. So here must be positive or 0. So I can plug here any positive real numbers. Can I plug negative? No, I cannot. Why? Because if I plug any negative number inside this radical, they will give me undefined. That means the domain must be the 0 and all real numbers, 0, 1, 2, 3, 4, or any real numbers like 1.1, 1.2, 1.5, whatever real numbers positive, and 0. The negative is undefined. If I plug any negative, will give me undefined. Why? Because here we have even number 2. Okay. So this is mean x such that x is greater or equal 0. Mean all real numbers, all the positive real numbers, and the 0. All positive real numbers and 0. Make sense? What is the domain? For the third one, who will do it for me? This is again look like this. Who will find the domain for this one? So ask yourself, which numbers can I plug in inside this expression and make me define? And still the expression will be defined.
Wouldn't that be the same as the one above it?
The same like one above it, but
As in, what you said, all positive real numbers and 0?
can I plug the 0 here?
No, you can't, because anything over
Exactly.
0 is undefined.
Exactly. So here the same exactly like before, look, like this one. But the problem here, I cannot, the 0 will be accepted. The 0 will not be inside this, inside the domain. Why? Because 1 over 0, if we look into all expression, they give me undefined. So the answer, it's look like this one, but we remove the 0. We're going to remove the 0. So it'll be like x such that x greater than 0 without the equal. Okay, so all positive real numbers. Make sense? Anyone has a question? So I give you right now like simple expression. Now I'm going to give you another example such that in this example a little bit like more harder. Same things. So now we know the general idea for domain. I ask myself, which number can I plug it inside this expression that make the expression well defined? So now I'll give you another example. Find the domain. Find the domain for first one, 2x squared plus 3x minus 1. Second one is 1 over x minus 5. Who will solve the first one? And who will solve the second one? Who will do the first one? Anyone like, okay, we will do it together. Can I plug the 0 inside the first one? This is a polynomial. Can I plug the 0 inside this polynomial? Yes, right? I can plug the 0. Y still will be defined. Can I plug any positive number? Is it possible? Yes, I can. What about negative? Also, yes, I can. So here, the domain will be all real numbers, everything. Makes sense? So the domain be all real numbers. So I can plug positive, negative, and anything. Make sense? And question? For the second one, can I plug the positive numbers here inside this one? If we look into this one, we just looking how we can remove the 0 from the denominator, right? Because 1 over 0, it give me undefined. So I'm trying to remove the 0 from the denominator. What number I plug it here inside the denominator, they give me 0.
Positive
What's
5, right?
5, exactly. So I have to remove the 0 from the denominator. I have to remove the number 5 from the denominator. This is the first step. Now, I look into the numerator. Is it polynomial? Is it good? Yeah, it's 1. So I don't have any problem here in the numerator. So what's the domain can I think for this one? All numbers except the 0 for the denominator. Except number 5. So it will be like x such that x not equal 5. This is mean all real numbers except number 5. Why? Because if I plug number 5 inside this expression, will give me 1 over 5, 1 over 0. And 1 over 0 is undefined. Any questions so far? If there is no questions, let me go to the second part of this chapter, of this section. Now we're going to simplifying rational expression. What does that mean? So, first things for simplifying rational expression, we have to factor both of the numerator and denominator. Then after we factoring from like a previous section, we're going to use this property. So first things, we have to factor both of numerator and denominator. Second step, using this property. AC over BC equal AC. This is mean I cancel the common factor. So here we try to cancel the common factor, C with C. Okay, they give me 1 over C. Let me give you example and explain how we can do that things. So example, If I have something like that, simplifying, this expression, I have x squared minus 1 over x squared plus x minus 2. Who will do that? How can simplifying this expression? First step, going back here, I have to factor both of the numerator and denominator. Second step, I have used this property. What is the factoring for the numerator and denominator? What is it? What is the factoring? What's the factor for x squared minus 1?
X squared.
No, from like, this is a different square.
What's the code? It's gonna be x x plus 1, then x minus 1.
Yes. So this is the difference between different square. This is me in like a previous section. I said if I see something like that, a square minus b square, this is equal, the factor for something like that is a minus b times a plus b. Here the same things, x square minus 1. 1 is like actually look like 1 or 1 square, right? So we're doing applying this factoring is x minus 1 here, like he said, x plus 1. Now, what's the factoring for the second part? What's the factoring
X
for the
plus 2 and x minus 1?
minus 1? So he like factoring like we do it last time. We factor the number minus 2 as minus 2. We're looking for two numbers such that the multiplication for these two numbers, they give me minus 2. And the summation of these two numbers, they give me positive 1. So plus 2 times negative 1, they give me minus 2. And the summation of positive 2 plus minus 1, they give me 1 positive, the middle one, the middle term. So this one minus positive 2 and minus 1 working for this polynomial. So the factor is x plus 2 times x minus 1. Okay, now we're looking for the common factor. We're doing the second, go back, we're going to using this property. If any common factor, we cancel it. What is the common factor between the numerator and denominator?
X squared.
No,
What's the goal? The x plus 1 will cross out x minus 1 at the bottom.
no. So he said x plus 1. He mean like x minus 1. So look, x minus 1 and x minus 1 are similar. So we cancel it. X minus 1 and x1 minus 1, they cancel each other. Okay? Because they are common factor for both numerator and denominator. Then this is what equal x plus 1 over x plus 2. Okay? X plus 1 over x plus 2. And this is the answer. Makes sense? Here, this step here, we cancel the common factor. Cancel the common factor. Make sense?
Yes.
Okay. Now let's go to another things. Any question before we go to the next part?
I have a question.
Yes. What's your
What kind of symbol do you have next to the 2?
next
On the side.
here?
No, on the
This
on-
one?
yeah, right
Here,
there.
this is
Plus
plus 2
2. What's next to it?
multiply
Okay.
minus 1.
So 2 times -1.
Yes, 2 positive 2 times negative 1, and down 2 plus negative 1. Let me write it again. So here we have 2 times negative 1. They give me negative 2, the third term, and 2 plus negative 1. They give me 1, the second term. Okay, James. So you can leave it and join right now. I will accept you.
Could you go back one slide just for a second and finish?
Okay.
writing?
Yeah, sure.
Okay, I'm finished.
Okay, thanks. So any question here? Don't forget this how to factor is called completing complete difference square here. Here, difference square. Now let's go to the how to we multiplying and dividing rational expression. So now multiplying and dividing rational expression. By the way, I post in the Blackboard the link for all the notes, for all lecture notes, and also I posted the recording video on YouTube. If you miss anything or you need like to know how we simplifying anything, just go back to the recording video, or you can go back to the notes. Okay. So now multiplying and dividing rational expression. So again, the same idea. First thing we have to simplifying. Then second things, I'm going to give you another property and you're gonna use it for doing the multiplication rational expression. So here, multiplying rational expression, just you have first things you have to factor. Why? Because it makes the multiplication easy. So first things factor, second things try to simplify, like here, like previous example. Third things, the important things, we have to use this property. It says A over B times C over D. This is equal. We multiply the denominator together and we multiply the denominator together. So I get one fraction, AC BD. BD, sorry. Make sense? So factor, simplify, use this property. Then we will get the answer. Let me give you example how we can multiply a fraction, Rational expression. Example. So multiplying this one, x squared plus 2x minus 3 over x squared plus 8x minus plus 16 times 3x plus 12 over x minus 1. This is equal. So I have rational expression. Why? Because this is polynomial over polynomial times rational expression, polynomial over polynomial. Now the question is multiplying both this rational expression. Like I said before, first step, factor both numerator and denominator for both of the both of the fraction. Simplify, then use the property. What's the factor for this one? What's the factor for numerator and denominator for the first fraction? What's the factor for this one?
X plus 3 and x minus 1.
X plus 3, x minus 1. Okay, let me make sure. 3 positive times minus 1, they give me negative 3. This is true. 3 positive plus negative 1, they give me 2. Yeah, this is the factor for the numerator. This is true. Down. What is the factor for the this is the factor for numerator. What's the factor for the denominator?
Is
the
it
fact-
4 x plus 4
X plus 4,
and x plus 4?
x plus 4. Okay, 4 times 4 is 16 and 4 plus 4 is 8. Yes, this is work. For the second one, what's the factor?
Three parentheses x plus 4.
3 parentheses x plus 4. Why? Because here the 3 is the common factor, is the greatest common factor. So here, the number 3, like we learned in the previous class, 3 is the greatest common factor. So we brought outside, we open parentheses, x plus 4. Here, what's the factor for x minus 1?
X minus 1.
X minus 1. Now, we're simplifying. What is the common, whatever common factor we cancel together? So what I can cancel here?
X plus 4 and x plus 4.
X minus x plus 4 with x plus 4. Okay, what else? What can I cancel?
X
minus
minus
1.
With x minus 1. What else? That's it. We don't have anything to cancel. Now we do multiplying. 3 times this parentheses, and here is 1 times this parentheses. So 3 times this one, x plus 3 over 1 times this one is the same, x plus 4. And this is the final answer. Any question for multiplying?
Yeah. Why don't you just multiply the 3x plus 3 times 3? So it could be 9. So it could be like 3x plus 9.
Yeah, I can do that, yes. But I can do that, or I can do, we like distribute the 3 inside the parentheses. They give me 3x plus 9 over x plus 4.
So both answers would have been correct.
Yeah, both of them are correct.
Okay.
Now, for dividing Rational expression. So the same steps like before, factoring, simplify, use this property, okay? So factoring, I mean for factoring, you factor both of the numerator and denominator for all fraction. Simplify, use this property, a over b divided by c over d. This is equal a over b times d. We flip d over c. We flip the second fraction and we change the division to multiplying. Okay. Let me give you example and explain how we can divide Rational expression. Okay, example. So if I have something like that, x minus 4 over x squared minus 4 divided by x squared minus 3x minus 4 over x squared plus 5x plus 6. First things we have to, like I said, factoring. So this is equal exactly like this. What's the factor for x minus 4?
X minus 4.
X minus 4. What is the factor for x squared minus 4?
That would be x plus 1 and x plus, or x minus 2.
X plus 2 times x minus 2.
Yes.
Okay. For this one, x squared minus 3x minus 4, what's the factor?
X times x minus 4 times x plus 1.
X minus 4 times x plus 1. Let me make sure. Minus 4 times 1 is minus 4. Minus 4 plus 1 is minus 3. Yes. Last one. What is
That
the
would be
factor?
x plus 2
X plus 2,
times x plus 3.
x plus 3. Perfect. Second things, we have to do this one, then we simplify. Hold on. Here's some mistake, small mistake. Let me just correct it. The simplifying, it's in the end. Here, use this property. Then we simplify. Okay. Factoring, we factor. We will use this property, then we simplify. So now using the property. So again, we flip the second fraction. We flip this. So this is equal x minus 4 over x plus 2 times x minus 2 times, we flip this fraction. So we have x plus 2, x plus 3 over x minus 4 times x plus 1. Makes sense? Now what we can cancel?
X minus 4.
X minus 4 with this one. And what else?
X
2.
plus 2.
So x minus 4 with x minus 4. What else? X plus 3. X plus 3 with, I can cancel it with, no, I don't
X
have,
plus 3.
no. What about x plus 2? Yes, x plus 2 with x plus 2. What else? I think that's it. We don't have canceling. Can't cancel more. So the answer is x plus 3 times 1 here. Give me x plus 3 over x minus 2 times x plus 1. X minus 2 times x plus 1. Any question? Anyone has a question? Okay, now let's go to the adding and subtracting rational expression. Adding and subtract rational expression. Same things, we have to factor, then we use this property. No, here we have to factor, then we have to make the both of the numerator and denominator are equal by using the least common denominator. Then we use this property after we make the denominator are equal. A plus B over C. We're factoring, we're looking for the least common denominator, then we use this property. Okay, let's go give you example for adding. So here we're doing for here for adding. Start for adding, then we go to subtract rationing. Example. 3 over x minus 1 plus x over x plus 2. First things, we have 4 minutes left for this class. So let me do this example and I'm going to stop until here. First things we have to factor. What's the factor for both the for the first fraction? What's the factor for 3? Still a 3, right? What's the factor for the denominator here, x minus 1? It's factored already. For the same things here, what's the factor for x?
X.
X, what's the factor for x plus 2?
X plus.
It's the same, it's factored. Now we're looking for the least common denominator. Least common denominator, like first or second section in this class. So the factor of x minus 1 is x minus 1. The factor for the second denominator of x plus 2 is x plus 2. So what we have to do? So we have to multiply this fraction by the factor of the second fraction for the second denominator by x plus 2. So we have multiplied this one by x plus 2. And here x plus 2. Now for the second fraction, what we have to multiply, both numerator and denominator, by this guy, x minus 1. Here we have x minus 1. So look, now both of the denominator are equal. X minus 1 times x plus 2, x plus 2 times x minus 1. Now using the property. So using the property. So I have the first one is 3 times x plus 2 plus second one is x times x minus 1. And the denominator are x plus 2 for both of them times x minus 1. Here I have x plus 2 times x minus 1. So the denominator are equal. Now we sum the both of the numerator. So what is the answer? We can distribute the 3 inside and the x inside too. So they give me 3x plus 6 plus x times x is x squared. X times minus 1 is minus x over x plus 2 times x minus 1. Now I can, like this one, I do a summation between the fraction, between the variables, sorry. So they give me x squared. 3x minus x is plus 2x and plus 6 over the denominator, x plus 2 times x minus 1. That's it. So next time I'm going to go over this example again, and I will explain it more. Any questions so far for this class?
No, but thank you. Bye, Professor.
Have a good night. So I will stop recording for this class.
Good night.